Okay, we've talked about designing a test suite. That is, finding a set of samples of inputs and expected outputs that we can use to test whether our code's doing what we expect it to or not. And we talked about both black box testing and glass box testing as ways of designing test suites. What happens when we're ready to actually start doing the tests? What should we do? Here, and we're going to do an example a little bit later on in this lecture, here what we're going to do is alternate between two important parts of testing. We're going to start with what we call unit testing. That says take a module, a function for example, and check it. Check it on input values whose results we know what to expect. Run the suite basically on the module to make sure that the module runs well. This will catch algorithm bugs. That is, places where I've got a bug either in how I encoded the algorithm or in terms of how I thought about the algorithm. Once I've checked the modules, I'm going to move on to what we call integration testing, which is to check that the system as a whole works correctly. If I got multiple functions that are interacting with one another, I want to make sure that even if the modules do the right thing, that the whole system does well. And this will typically catch what we might call interaction bugs. And by that I mean places where an incorrect value is being communicated to another function, or an assumption about input is being broken as I move back and forth. And once I've done that, I want to cycle. I want to go back around and, having done integration testing and fixing things, go back and check the modules as unit testing, and then check integration testing, and cycle until I'm convinced that I've caught all the bugs that I'm likely to find. So we're going to think about how we deal with doing unit testing and integration testing. Now, there's another piece of testing that's really useful to do, and that's to build a test driver. What does that mean? Well, drivers are code that actually set up to do the testing for us. So I'm not just typing in things in by hand. And the idea is that in a driver, we're going to set up an environment. And what we mean by that is we're going to set up a piece of code that creates bindings for global variables, data structures, other pieces that I need to do the testing. It's then going to take that test suite, that sequence of inputs, and run the code in each one, and save the results and report back out. So a test driver is basically a piece of code that does the testing for us, builds the environment, takes and implements the test suite, and runs it. Nice thing about drivers are that they basically simulate parts of the program that use the unit being tested. So they're going to do the actual simulation of the testing that we want. Now, if there are interactions with other pieces of code, what happens if we haven't already debugged those? And there we can often use what's called a stub. And a stub simply simulates parts of the program that are used by the unit being tested. And when I say simulate, if I've already built the code and it runs, great. But even if I haven't, I can still get the same effect. For example, by building a table of input-output pairs and using that to simulate the behavior of that particular piece of code. The advantage of a stub is that it's going to allow you to test units that depend on software even if you haven't written it yet. Maybe I'll not be able to test everything, but remember, since I'm building a test suite with a particular set of cases, I can basically say, well, if this code was there, here's what it should do. And that stub will let me go back and actually fix, or test rather, the piece of code I'm testing inside of the driver. So, I'm going to get to testing in a second, but what does that say then? It says, having built a test suite, I start with unit testing. Having tested all the units, I'm going to go to integration testing. And I'm going to cycle back and forth. But one of the key things to remember is when I've done debugging and I think my code has been corrected, it's really important to do what we call regression testing. That is, go back and check that the program still passes all the tests it used to pass. Even though a piece of code may have run correctly before, because I've changed things, there's no guarantee I haven't accidentally messed something up. And so a really good practice is to go back and rerun the tests I'd run before to make sure that they still work. And that regression testing will ensure in a sort of principled way that the tests I'm running are actually running correctly.